Example 22. Given A is a matrix containing the elements 1, 3, -9, 5, -1, 3, 1, 3, 7, and B is a matrix containing the elements 1, 3, 0, 2, -1, 3, -1, 0, 1. Find AB and A inverse. To find AB, we multiply matrix A and matrix B together. This gives us 16, 0, 0, 0, 16, 0, 0, 0, 16. Factoring out the 16 here gives us 16 multiplied by the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Therefore, AB is equal to 16I. Multiplying both sides by A inverse gives us A inverse AB is equal to 16 A inverse I. As we know, A inverse A is I and IB is B. So now we get to reduce it to B equals to 16 A inverse. Making A inverse the subject gives us A inverse is equal to 1 over 16 B. To find A inverse, multiply 1 over 16 with matrix B, whose elements are 1, 3, 0, 2, -1, 3, -1, 0, 1, as given in the question. This gives us the matrix containing the elements 1 over 16, 3 over 16, 0, 1 over 8, -1 over 16, 3 over 16, -1 over 16, 0, 1 over 16 to be A inverse. Hence, solve the following linear equations. X plus 5y plus z equals to 7, 3x minus y plus 3z equals to 5, -9x plus 3y plus 7z equals to 1. Going by our understanding of Ax equals to B, which goes on to give us x is equal to A inverse B, let us look at the matrix equation we have here. The matrix containing the elements 1, 5, 1, 3, -1, 3, -9, 3, 7 is equivalent to the transpose of matrix A given in the question. We shall denote the matrix containing the elements x, y, z as X and the matrix containing the elements 7, 5, 1 as P. We are calling it matrix P because we want to avoid any confusion as we already have a matrix B given in the question. Now this gives us A transpose X is equal to P. Multiplying both sides by the inverse of A transpose leaves us with X equals to the inverse of A transpose times P. Do take note that the inverse of A transpose is equivalent to the transpose of A inverse. So, we rewrite this as X equals to A inverse transpose times P. We substitute X with the matrix containing the elements X, Y, Z. The transpose of A inverse is found by interchanging the rows and columns of A inverse obtained in the previous part of this question. The transpose of A inverse is 1 over 16, 1 over 8, -1 over 16, 3 over 16, -1 over 16, 0, 0, 3 over 16, 1 over 16. Matrix P contains the elements 7, 5, 1 from the right-hand side of the linear equations given. Multiplying A inverse transpose with matrix P gives matrix X to be 1, 1, 1. So, equating this to X, Y, Z gives us X equals to 1, Y equals to 1, and Z equals to 1.